So here we're going to talk about the Box-And-Whisker plot, sometimes known as the box plot. And in the Box-And-Whisker plot, we need a 5-number summary. So 5-number summary is what this is based off of. And we talked about how to find the 5-number summary in another video. So I'm just going to take the results from that 5-number summary. And so we've got the 5 numbers. So what we're going to do is we're going to plot this on a number line. And so my lowest number is 11 and my largest number is 35. So I'm going to run from 0 and I'm going to count by tens. That way I can get everything on there. Okay. So how does this work? Well, I'm going to put dots above everywhere that I see the numbers. So 11 is the first one, so I'm going to put a dot right here at 11. And then 23 is the next one. And then 25. And then 30. And then the last one is 35 right there. Okay? So once I get my dots, now I'm going to make my box and then my whiskers. Okay, the whiskers grow out on the side of the box. So first thing I'm going to do is I'm going to start with the inside box here. Okay, so I've got my box, right? And then I want to put a vertical line here to go through that median. And now that I have my box with my vertical line in the middle, I'm going to do my whiskers. So I have a whisker here, and I have a whisker here. And that's the box plot. The only thing left to do at this point is to label it. So the minimum is equal to 11. So I'm looking for the labeling. Q1 is equal to 23. So make sure to label. Q2 is equal to 25. Not 52, 25. And then Q3 is equal to 30, and last, the maximum is equal to 35. If you call Q2 the median, that's fine. Okay, they have different names there, so as long as you label it, that's completely okay. All right, so this is how you do a box plot. All right, it's literally a box with a line through the middle of the box, vertical lines, and then you put whiskers on both sides of the box, connecting out to the max and the min. Now, this inside range in here is a special thing called the interquartile range. So the interquartile range, also abbreviated IQR sometimes. This is equal to, well, what is the range from? It's from Q1 to Q3, right? So it's the range from Q1 to Q3. So it's Q3 minus Q1. That's how I get the range. So my range here would be equal to 30 minus 23, which is equal to 7. So the interquartile range, this range here, is equal to 7. Okay? So this is what I like to call the middle 50, okay? So it's the middle 50%, right? Why do I say the middle 50% here? Well, if you think about this being the middle 50%, there's 25% over here, and there's 25% over here, right? Each one of these box and whiskers represent a 25% block because of the quartiles. All right, quartile 4, right? So the interquartile range is like that inner 50% of the data. Ranges in this 23 to 30 range there. So this is the measure of variation that gives the range of the middle portion of the data. So the middle, I like to think of it as the middle 50. Okay, that's how I think of it. All right? Now, it is possible to have outliers, and we talked about outliers in another video, but this one we're going to have a mathematical definition of how to find outliers. So to identify outliers, how do we do this? We multiply the interquartile range by 1.5, okay? So what is that? The interquartile range was equal to 7 here, so to 7 times 1.5, I get 10.5, okay? And then what do? I go from Q1 and I minus my interquartile range times 1.5, so that's 10.5. And then I add on the Q3, 10.5. So what does this mean? So if I'm an outlier, that means I'm for sure outside of my inside range, right? But I'm outside of it by a distance of 10.5 this way. So that means I have to subtract 10.5. And I'm outside of it by a distance of 10.5 this way, meaning I add 10.5 to get outside of it. So the question is, where do I fall? Do I fall far enough outside to be considered an outlier? Well, let's look at this. So what is Q1 equal to? Q1 was 23. So 23 minus 10.5, that gives me 12.5. And then Q3, what was that? That was 30 minus 10.5 equals, plus 10.5 equals 40.5. So you're not an outlier if you're inside the range 12.5 to 40.5, okay? But if you're outside that range, then you are an outlier. Let's go back and look at the original data. So I'm going to take the original data here, right? So I'm going to take that original data. Now, are there any values that are outside this range? Well, 35 is the biggest, right? So that's inside the range. So all of these are good, right? All those are good. Where do we end up being bad? There's only one value. It's 11. 11 is an outlier. Why is it an outlier? Because it's outside the interval of 12.5 to 40.5. So in general, to identify outliers, so outliers are Q1. So if we're outside this interval, okay, so let's define it like this. So outside the interval, and so the lower bound is Q1 minus the interquartile range, which is different for each one, times 1.5. So that's the lower bound, that's the low number, okay? And then the upper bound, Q3 plus interquartile range times 1.5, okay? And so that's the upper bound. So that's the high number. Okay? So outside the interval here, then we have an outlier. And that's exactly what 11 was. It was outside of that interval there.